laws of chemical combination. Now, simple activity will explain to you what is this law of chemical combination. Say you take two types of chemicals and label them as X and Y. X you have, say, barium chloride, and Y is sodium sulfate. Or X you have as copper sulfate and Y you have sodium carbonate, or any such pairs you develop. We can choose any one salt from, say, X. For example, let us choose barium chloride. So here there is barium chloride in the conical flask. Now we take a smaller tube, which is called usually ignition tube. Now we fill this ignition tube with, say, sodium sulfate. We are hanging it with a thread. Then we close the mouth of the flask with the help of a cork. Now shake it and then see what happens. Now if we take weight before we shake the two contents and then again take weight after we have shaken the content, what we find is that although the color has changed, new substances have been formed, still the weight is same. Now which kind of reaction will take place? If we have taken barium chloride and sodium sulfate, then what we get is barium sulfate and sodium chloride. We started with this, ended with this, but the weight is same. Another question, why did we put cork here? Obviously, when we are going to shake, the contents can move out, they can spill out. Or if a gas is formed, it will diffuse out, and then we will not be able to know whether the weights remain same or not. So by many such experiments, it was found that the mass can neither be created nor destroyed. What does that mean? That it cannot happen that you start with 10 grams and then later on what is left with you is, say, 6 grams. This would mean 4 grams have been lost, destroyed. Or you started with 4 and what you got was 10. Like they say, if you do good deeds, you get good results. So it depends upon how much good deeds you have put in. Or in your case, how much of hard work you put in for your exam. Your result is going to be accordingly. So similarly, in the case of a chemical reaction, what was observed was that the mass remains same. So this law is called law of conservation of mass. Which states mass can neither be created or destroyed. Another law was law of constant proportion. According to this law, in a chemical substance, various elements are always in a fixed ratio by mass. For example, we may take water from any source. There will always be hydrogen and oxygen in it. and in the ratio of 1:8. For example, you can take 9 grams of water or say maybe 36 grams of water. In this case, 1 gram will be hydrogen and 8 grams will be oxygen. In this case, 4 gram will be hydrogen and 32 gram will be oxygen. In either case, the ratio remains same, 1:8. So, any amount of water, any source of water, it will always be made up of same elements and in same ratio. Now, there was another scientist called Dalton. He also experimented and then he reached certain points which he called as atomic theory. So, he gave us the Dalton's atomic theory. According to this theory, the first and the foremost point is that all elements, all substances are made up of the smallest particle which cannot be further divided, the indivisible particle, and he called it an atom. All substances are made up of very small indivisible particles. Called atoms. So everything, whether living or non-living, everything is made up of atom. And as per Dalton, today we know that's not true. The atom cannot be further divided. Second thing he said was, all atoms of an element are identical. In what? In mass and properties. Now what does this mean? This means that if you take the case of oxygen, now the given amount of oxygen will not have only one atom of oxygen, but all the atoms will have same properties, same characters, and they will be having same mass. For example, say you can take the case of a family. All the members of that family will have some common features, right? So we can immediately identify that, okay, this person belongs to this family. So similarly, in element also, it is not possible that some atoms would be different. There is a variation to this also, but we will come to that later.